Hello and welcome to the another tutorial of this Blockzie module. Here we make your coding journey easy and fun. So in the previous lecture we have seen how one can interface the different things with Arduino Uno. After that now are here with the sensors interfacing. So now in this particular tutorial we are going to learn how one can interface different sensors in Arduino using Blockzie. So in here we are going to learn about DHT11 sensor interfacing, potentiometer interfacing, soil moisture sensor interfacing and servo motor interfacing. This is our table of contents in which we have four different parts. In first we are going to see the interfacing of DHT11 sensor. After that we are going to see the potentiometers interfacing. In the third part we are going to see the soil moisture sensor interfacing, and in the fourth part we are going to see the servo motor interfacing. So let us first start with our first sensor, which is DHT11 sensor. So this DHT11 sensor, first of all, this is how it looks like. So DHT11, or you can say DHT11 sensor, it means here DHT represents, first D is there for digital, after that H is for humidity and T is for temperature. So this DHT11 sensor is a low cost digital sensor which is used to measure or sense temperature and humidity, that can be used to measure in various applications. So this particular sensor is capable of measuring temperature ranging from 0 to 50 degrees Celsius and humidity from 20% to 90%. Now this particular device or sensor is digital, hence it provides output in the form of digital, making it easy to interface the sensor with different microcontrollers and other digital devices. The sensor consists of capacitive humidity sensor and a thermistor based temperature sensor. So this particular sensor has three main components. The first component is the humidity is the humidity sensing component. So it has a capacitive humidity sensor in which we have two different electrodes, and between these two electrodes we have one moisture holding substrate. After that, the second main component is, you can say, NTC temperature sensor, or you can say thermistor. So it is a thermistor based temperature sensor using which the sensor will measure the temperature. And the third part is the main component, which is 8-bit microcontroller IC, which is at the back side of your sensor, and it communicates with the microcontroller through single wire digital interface. So it uses a single wire communication process. It is commonly used in home automation systems, weather stations and other projects that require monitoring of temperature and humidity levels. Now this particular thing has two different parts. First one is DHT11 sensor, and after that you have this DHT11 module. Now this sensor has four different terminals, whereas this module has three different terminals, naming signal pin, VCC pin and ground pin. So using this signal pin you are going to get the output, and the output of the temperature and humidity in the form of digital. After that we have one power pin, which is VCC, which is used to supply the 3.5 to 5.5 volts to the component. And the another pin is ground pin, which is used to connect your device with the ground pin of the microcontroller. So let us start with our next step, which is how to interface this DHT11 sensor with Arduino. So in some of applications, or just we previously said that you can use this DHT11 sensor to measure temperature and humidity. So if you are building a project or anything like that in home automation, you can use this and you are good to go. So interfacing this DHT11 sensor with Arduino helps to read temperature and humidity from DHT11 sensor. Now in this project we are going to measure the room temperature and humidity, and this both values are going to be printed on the serial monitor window of our Blockzie software. So we are going to interface both this module with our Blockzie module, and in Blockzie we are going to give the commands, or you can say we are going to provide the task what the DHT11 has to perform. So using Blockzie we are going to block code. So for that, these are the hardwares which we are going to require. The first one is Arduino Uno board. After that, we are going to require this USB A to B type cable to connect your Arduino or microcontroller with computer or laptop. So you are going to also require a computer or laptop, few jumper wires, and also a DHT11 sensor, and in which you are going to block code your devices is Blockzie. So the software you are going to require is Blockzie. This is the circuit diagram, or this is how you are going to connect your DHT11 sensor with the Arduino or this microcontroller. So this is in case this is our microcontroller and this is our sensor. So the VCC pin of DHT11 sensor is connected to the 5-volt pin of Arduino Uno board. As you can see here, this 5-volt pin is connected to this VCC pin. So this is the power pin which is get connected to the 5 volts pin on Arduino Uno board. After that we have this signal pin or data pin. So data pin is connected on the pin number 2 of the Arduino Uno board, and the ground pin is connected to the GND pin of Arduino Uno board. So this is how you are going to connect your DHT11 sensor with Arduino Uno. After that, what you will require is you just need to connect your microcontroller with your laptop or computer. So now we are going to see how one can set up this on Blockzie software. So for that, for this particular tutorial means DHT11 sensors interfacing with Arduino in Blockzie, what we are going to require is first open Blockzie software, and after that connect your Arduino Uno board, select Arduino Uno from the toolbar, and after that change the mode to upload mode. After that, click on this add extensions and select the sensor, which is DHT sensor. After adding this extension, we are going to block code and give command to a sensor. So this is the coding for sensor. So when first is used when Arduino Uno begins. After that we have initialized our DHT11 sensor, which is connected specifically on pin number 2. Now we are giving the speed. This is the speed of communication. We have used this block, which is serial begins baud rate, which is 9600. So we have used this particular speed. After that, what we need to require is DHT11 sensor is there to measure the humidity and temperature. So we are going to measure the temperature, and accordingly we are going to give the output. So here we are going to use the temperature measurement particular session. So here we have used this temperature block. So first of all, we are giving a condition that what we require is we are making a code for sensor. When sensor senses the temperature greater than 30, then what should happen? And if the temperature reading is less than 30, then what should happen? So as we all know that up to 30 degree you can call the room temperature as normal, right? If it exceeds, if it is more than 30, then you feel a little bit warm or hotness in temperature or in your surroundings. So we are making this condition using this if and else block. So in if we have added a condition which says that if the DHT1 sensor reads the temperature and that particular temperature is less than 30, So whatever temperature is going to get read by the DHT11 sensor is less than 30, then you can say that your room is at normal temperature. So we are going to print this on serial monitor using this block which says serial print dash 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 and drag. So what we need to give output as that yes, the room temperature is normal. So we have written this particular that yes, the room temperature is normal. And if the temperature is more than 30, then it should print that temperature is hot. So this is how you can interface this particular sensor DHT11 and decoding for this. Now let us see the step-by-step process for DHT11 sensor and Arduino Uno interfacing in Blockzie. First of all, open Blockzie software. After that, go to this no device selected. From that, select this Arduino Uno board and the port onto which you have connected your Arduino Uno board. After that, you'll see that this particular will be transformed from unconnected to connected, and we are using this upload mode. So this just switch over your mode from real time to upload mode. Now we need to connect different blocks for DH to enable our DHT11 sensor. Hence I'm just going to click on this add extension, and from add extension I am adding this extension to get the blocks for coding our DHT11 sensor. So I'll just click onto it, and it says that yes, the blocks for this has loaded. So you will see that in block programming palette this DHT sensors related blocks are available. So let us first see the different blocks. It has three different blocks. The first block is there which says that initialize DHT1. It has pin and model, means on to which pin you have connected your DHT1 sensor with Arduino Uno is going to be selected. Now it is digital, so we are going to use from pin number 0 to pin number 13. So on whichever pin you are going to connect your DHT11 sensor, you just need to specify from here. After that, which particular module do you are using? If you are using DHT11, DHT21 or DHT22. So just specify, or you can say just click onto it and that particular will be there. So right now we are using DHT11 sensor, so I am just checking onto DHT11 and the model is selected over here. After that, this DHT sensor is there to give you output for humidity and temperature. So it is going to read the humidity level or the temperature. So these are two reporter blocks which are there to get the result of humidity or temperature. So what we are going to use and which kind of result we want to see, that particular blocks you need to just add in sequential manner and you will have the output. So let us first start. So for that we are using first is this event block which says when Arduino Uno begins. So when Arduino begins, what we need to do is we need to get output that your sensor is sensing, and if that sensor's temperature sensing part is exceeds the room temperature, it should indicate that the temperature of your room is hot, and if it is at normal temperature it should print or it should give output as yes, the temperature is normal. So for that we will be needed one condition block. This is our condition block, and the condition we are using is if then else. Now what condition is, from operator block I am going to use this block which has this less than option. Means for now we are using this read temperature. It says the DHT1 will read the temperature, and also it has two different options, whether you have degree Celsius or degree Fahrenheit, in which you want to see your output is up to you. So I am using this degree Celsius. And if the temperature of room is around 30, then your temperature of room can be called as normal temperature, right? So I am just using this as 30. If the temperature reading on the sensor is less than 13, then you can say that your room is at normal temperature. So I'm going to use this serial block which says this. So that condition is going to fulfilled by this, that if the sensor's temperature is less than 30, then your room is normal. So I'm going to just print it on serial monitor that the temperature is normal, right? If the temperature is not less than 30 and is exceeds 30, then your temperature of room is more. Hence we are using this particular block which says temperature is hot. So your temperature of room is hot, or your room is hot. You can use any. And I want this on repeat, right? So this is our condition. Now after that, what we are going to require is, first we need to initialize our sensors. So yes, our sensor is connected on the pin number 2 of Arduino Uno board, and we have this DHT11 sensor. After that, I am using just a one block which has serial begin baud rate, means I am fixing the baud rate at 9600, and this is the code which you can use in your DHT11 sensor, and you can check its value. If your sensor senses the temperature which is less than 30, then it will print here which is temperature is normal, and if the room temperature increases beyond 30, then it will print as the temperature of room is hot. So this was all about the DHT11 sensor and how you can code it in Blockzie. Let's move forward and see the potentiometer interfacing. So in the second part, we are going to see what is potentiometer and how one can connect it for using it as a variable resistance or to control the other devices. In this particular, we are going to see first what is potentiometer. So a potentiometer, you can see it as it is a three terminal device. It has 1, 2 and 3 terminals. So it is a three terminal electrical component that can be used as a voltage divider, or you can say a variable resistor. It consists a resistive element and a contact that can be moved to change the resistance. Now there are several types of potentiometers, and you can classify them in several ways. There are linear and logarithmic potentiometers which are classified onto the relationship between resistance and the length. After that, we have rotary type and sliding type potentiometers, which are described as the movement of vapor. So these are the different types of potentiometers which are available in market. But basically, a potentiometer is a three-terminal component which is used to control electrical resistance. Now it consists of a resistive element, a rotating contact called vapor, and two fixed terminals. The resistive element is used usually of coiled wire or a carbon film, and the vapor is connected to a rotating mechanism. So it has a rotating mechanism, and that vapor is connected to that mechanism, which allows it to move along the resistive element. And by moving the vapor, you can change or control the electrical resistance. This is how the potentiometer looks like. The three terminals and the resistive element. First terminal is VCC, which provides supply voltage. After that, second is output, means from which you can get the output. And the third is ground, which will provide a ground connection, means it is going to be connected to the ground pin, and using this you can supply the voltage. So in here we are going to control the LED's brightness using Arduino and potentiometer. So potentiometer is used to control the brightness and Arduino is our microcontroller. So in this project, we'll change the LED's brightness by rotating the potentiometer's knob. Here you can see that a potentiometer has a knob, and this knob is used to change the brightness. Means after changing, you can see that the LED's brightness will be changed as per the change in the potentiometer. So we will increase and decrease the LED brightness value between 0 to 255 according to the changing potentiometer output, which is between 0 to 1023. Now the potentiometer is here going to perform as an analog device, which is going to change its value from 0 to 1023, means it will attend all the in between quantity from 0 to 1023, giving output as the change in the LED's brightness, also from 0 to 255, means from lower value to its higher value, and also in between lower and higher. When the potentiometer output value is 0, means at the 0 point your LED will also be at its 0 potential or 0 value, which will give you result as LED in its low mode, or you can say in off condition. When the potentiometer's output would be 1023, means potentiometer's output at its high, then as a result you will see the LED's input value would be the 255, means the LED will be having 255 as an input, means your LED will be at its higher position or higher mode, which will give you LED as its full brightness position. So these are the hardwares which you are going to require to build this project. So first one is Arduino, which is a microcontroller. After that is a USB A to B type cable to connect your Arduino board with your computer or laptop. Few jumper wires, a breadboard, one LED, one potentiometer and resistors. And the software using which you are going to give command is Blockzie. This is the circuit diagram to follow the project. So here the potentiometer's ground pin is connected to the ground pin of Arduino. The supply or power pin is connected to the 5-volt pin on Arduino board, and this one output pin is connected to the A2. Means from collecting the data or reading the data from analog, it will be given to LED, and after that data from microcontroller it will change its brightness, means as off, on or dim. So LED is connected onto pin number 11, and the cathode of the LED is connected to the ground via a resistor. So this is the code for controlling the LED's brightness using a potentiometer with Arduino in Blockzie. Now let's see the coding part in Blockzie. So here we are using the Arduino Uno as a microcontroller. So let us first go to choose a device, and after that we are going to choosing our Arduino Uno, and here we want here we want to change the light LED or light emitting diodes brightness using using the potentiometer. So what we are going to do here is we are making a potentiometer as an input device, and as we turn that knob of potentiometer, the LED's light should be accordingly changed, right? So here the input device, or you can say as an input, we are using the potentiometer, and that particular input of means whatever in whatever direction you are moving your potentiometer's knob, that particular input would be given to LED. So according to the input given by the potentiometer, your LED would behave, or in other words, LED will be glowing, dim, on, off, in whichever state the input it gets from potentiometer. So here we don't need to add external extensions. First we need to make this an upload time, and hence we are using the Arduino begin. So when Arduino begins, what it should do, that first is we need to make clearance, or we need to declare that on which pin we are attaching the potentiometer and on which number of pin we have used LED. So first we are using this, that on the pin number A2, because the potentiometer's output is in the form of analog, we are using the potentiometer on analog pin. Hence we are using that particular A2 pin as input, because we are giving instruction, or we are rolling that input knob, and after collecting that particular input from potentiometers, we are controlling the LED. Hence we are using the mode as input. After that we have connected the LED on the pin number, we have connected that on 11, because the pin number 11 is also a PWM pin. As we have discussed earlier, that on Arduino Uno board there are 6 PWM pins. PWM means pulse width modulation, means you can control and vary the output, so it will give you result in the form of PWM mode. Hence we are using this pin number 11, and also that particular LED is our output device, because we are getting the output which is in the form of light emission. Hence the pin number 11, which is PWM pin, is set as output. Now we are using a control block, which is a forever block, and what we need to do is we are going to set output, means that PWC, here we have this set PWM pin block, so we are using this particular block, and pin number 11, we have used the pin number 11, as I have just told you that we have in total 6 PWM pins, and on the pin number 11 we have connected the LED. So what we need to do is the pin number 11, which is also a PWM pin, its output should be what? So it should read the analog pin. Whatever the input given by this particular pin would be the output of your LED. Means if your knob or potentiometer's knob at its lowest, then the LED in return will be turned off, and if the potentiometer's knob is at 1023, or you can say at its highest point, then the LED connected to it will be higher. And also you can see and check the changes in between 0 means low and high. Accordingly, the brightness of LED would be changed. So the potentiometer is also something like you can see on dimmer switches, or you can say the voltage controlling knobs. So these are the device where you can apply that particular application of potentiometer. So using this potentiometer, here we have controlled the brightness of LED. And now the third part of this particular tutorial is about soil moisture sensor. What is soil moisture sensor and how one can connect the soil moisture sensor with Arduino and Blockzie. So let us see first that what is soil moisture sensor. So a soil moisture sensor has this kind of two different modules. This is a one module which is going to be used to measure the moisture, and this is one which is going to be connected to the circuit or to the microcontroller to read and give the data. So first of all, the soil moisture sensor is the kind of sensor which is used to gauge the volumetric content of water. within the soil. So if you want to measure the moisture of your soil, then you can use this particular sensor, because it is used to gauge the or to measure the volumetric content of water within the soil. Now it has four different pins, as you can see in this particular part of module. It has four different pins naming A0, D0, GND and VCC. So first, this is AO pin, which is you can also refer to as analog output pin. Means this particular pin give us an analog signal between the supply value to 0 volt and will be connected to one of the analog inputs on your Arduino board. So this is going to be connected to the analog pins, from which in total has six different analog pins, and from this 6 pins you can connect this AO pin to any pin on Arduino board. After that we have D0, which is also referred as digital output pins. So this particular digital output pin gives the digital output of the internal comparator circuit. Means it has internal comparator circuit, and using this particular switch, you can switch or pin, you can get the digital output of the internal comparator circuit. Also, you can connect it to any digital pin on Arduino or directly to 5 volt. Means you can connect this digital pin on the digital pins of Arduino. After that we have this VCC pins. So this VCC pin supplies power for the sensors. Means using this particular pin you supply the power to this module. It is recommended to power the sensor between 3.3 volt to 5 volts. Means this is the recommendation for voltage. Please note that this analog output will vary depending on what voltage you provided for the sensor. Means these voltage applied to the sensor will be affected at the output part. Means whatever voltage you have given to this VCC pin, according to that particular input voltage, your output can be vary. After that, the fourth pin is GND. This particular GND pin is for ground connection. Means this GND pin gets connected on the ground pin of the Arduino board. So the you can say this particular soil moisture sensor is connected to Arduino board, and it is something like this can be used to gauge or to measure the moisture within the particular soil. So the soil moisture sensor uses capacitance to measure the dielectric permittivity of the surrounding medium. In soil, dielectric permittivity is function of the water content, and the sensor creates a voltage proportional to that particular dielectric permittivity and therefore the water content of the soil. So in return you can have the water content of the soil. So this was the working principle of the soil moisture sensor, and this is how the soil moisture sensor module looks like. To perform this interfacing part, we require this particular hardwares. The first one is Arduino Uno board. After that you are going to need one A to B USB cable, a laptop or computer, few jumper wires and a soil moisture sensor. The app which is in which you are going to perform your block coding is none other than Blockzie. So this is the circuit diagram. So first this pin is going to be connected with one of the pin here, and the remaining pin will be connected to the remaining pin on this particular sensor. After that these four pins are going to be connected, but first here we are going to use AO pin only. So this analog output pin is going to be connected on the any analog pin of Arduino Uno board. So we have used this A0 pin, and we have connected this A0 pin with the A0 pin on Arduino board. The GND pin is connected to the GND pin on Arduino board, and the VCC pin is connected to the digital pin. So we have connected this VCC pin to the digital pin number 7. on Arduino board. And this is the coding for soil moisture sensor, and we will see the step-by-step coding in Blockzie. Here we will see the coding part for the soil moisture sensor. So first of all, go to this and select Arduino board and change the mode from real time to upload time. After that, use this block which says when Arduino begins. So when Arduino begins, what happens is, first what we need to do is we need to set a baud rate. So we are using this particular block which is serial begin baud rate. So baud rate is 9600. After that, we are going to set a pin that we have used a pin A0 as input pin, because from that we are going to collect the data which will be detected or measured by the soil moisture sensor. So a particular pin is set as input or output. So here we have used the pin A0 as an input. So here the pin A0, whatever connected on A0 is going to be read by the microcontroller. So the soil moisture sensor as input and on pin A0. After that, what we are going to need here is whatever the sensor is measuring the moisture of the soil is going to be printed on the serial monitor over here. Serial monitor means over here. We want that what is the result of the soil moisture. So we need to see the result here. So for that, we are going to add a variable, and that variable is moisture. So we want to see the moisture. So we are going to just set this moisture to read the analog pin. So whatever the pin is going to read is going to set as moisture. After that, we need to print that particular value which is going to get result as print on serial monitor. So we will print that particular thing which is moisture. So first we have made the moisture to get data or to read the analog pin which is our soil moisture sensor. So it will first collect the data in this particular variable. It will get and it will store it in this moisture variable. So we have created here a variable to store the data from sensor. So this particular data is going to collect in the moisture variable, and that particular data would be printed on the serial monitor, because we have used this serial print. Whatever the moisture's value is going to be displayed on serial monitor. After that, we need result. What should be printed? We are going to print that moisture, but which kind of moisture? Means the soil is wet or the soil is dry. There are two types, right? Whether your soil is wet or your soil is dry. So we need to print accordingly. If the moisture of the soil is more than some particular value, then you can say that your soil is wet, and if the value of the moisture in the soil is lower, then it will be known as the soil is dry. So we are using the if else block for this particular function, if then else. So here we need again one operator block for less than this. Here, what is the thing? The thing is moisture. So moisture should be what? Then what should be printed? And for particular moisture, what should be printed on serial monitor? There are two conditions. If the moisture is less than this particular, then this should be on display. And if that is not, then this particular would be printed on the serial monitor. So here we are using right now value as 500. If the moisture level is lower than 500, then you can say that the soil is wet. And if the moisture of the soil is more than 500, then soil is wet. So it will give you a result accordingly, and we just need to make it in loop, means we are using the forever block. So this is how you can measure the moisture of the soil using the soil moisture sensor with Arduino and coding in Blockzie. So let's move forward to the last segment of this particular tutorial, which is the servo motor interfacing. In this particular part, we are going to see the servo motors interfacing with Arduino in Blockzie. First, we will see the basics of servo motor, then we will see its connection and in Blockzie. So the servo motors are among the most efficient motors which are used in various industries today. So these motors basically allow the precise control of an object's linear or angular position, velocity and acceleration, making them ideal for many jobs or motors can't do. For example, in automation or in robotics. But as simple as servo motors might appear, there is more to their operation than meets the eye. So for instance, servo motors have a unique working principle and come in several different types and capabilities. So these are the motors which are the most efficient motors used in several industries today. So this is one micro servo motor, and a micro servo motor has three different pins, namely ground, GND, 5-volt pin and control pin. So this control pin is input for the control system. This 5-volt pin is a positive voltage that powers this particular servo, and this ground pin is common for both motor and logic. So let us just quickly see its main logic or its main functioning. So the servo motor is part of closed loop system consisting of a motor, gear system, a position sensor and control circuit. The motor is connected to the gear system, which reduces the motor speed, increases torque and provide feedback to the potentiometer. Now this particular potentiometer converts the feedback signal into electrical signal and feeds the information into control circuit. The control circuit then decodes the signal and compares it with the desired position before it controls the motor's rotation precisely to achieve the desired position and give you the desired result. So this was the basic of servo motor. Now we will see the interfacing of servo motor with Arduino Uno, that how one can connect this particular with Arduino Uno. So here the connection is given, in which we have connected the GND and voltage pin, or you can say 5-volt pin. Here this GND and 5-volt pin, these are connected on GND and 5-volt pin on Arduino Uno board. After that we have connected after that we have connected this pin, which is control pin, the pin number 3. That particular pin number 3 is connected onto the Arduino's PWM pin, because this is going to give us a result in the form which can connect or which can be read or controlled using PWM pins. So these are the hardwares which we are going to require for this particular project. The first one is Arduino Uno board. After that is USB A to B cable. one computer or laptop, few jumper wires, and a servo motor. And this is the Blockzie software in which we are going to code. So this is the circuit diagram. So we have this 1, 2, 3, 4, 5, and 6 total PWM pins. You can use any of the PWM pin for this servo motor. Here it is connected on the pin number 5 or digital pin number 5 of Arduino Uno board. One is connected, GND pin is connected to GND, and the 5-volt pin is connected to 5-volt pin. And this is the coding to rotate the servo motor in Blockzie. So we will see now the Blockzie's block coding. And so here in Blockzie we are going to see the block coding steps. For that we are going to just select Arduino Uno, and in upload mode we will collect first block which says when Arduino Uno begins. So we are just going to rotate the servo motor. So for that we are using the block forever, and we are going to add the pins which says set servo. Here we have that this particular block for servo motor. So we have connected servo motor on pin number 5. So we are just selecting pin number 5. First we will rotate it at 60. After some point of time, and that some point of time is going to add as a delay using the wait block. After that we are making it 90, or you can say 120 degree. We are making a gap of 60 here, and again a 60's gap, and it is 180. Let's just reduce the time of delay, and this is the coding to rotate the servo motor in Blockzie. So this particular coding is you can use for different kinds of project. If you have connected anything on your servo motor, then according to this coding that particular thing will rotate, and you can use this in your project also.